my name is Derek from Tomcat Gas Training, and welcome to this gas tutorial all about this, gas pipe sizing. So in this video we're going to be going through step by step on how to complete the pipe sizing for gas according to British Standards BS 6891 2015. So that's the standard we're going to be using to be able to do that. So everything is taken out of here. So there are a few things we need. So first of all, we need a drawing of our pipe layout, including lengths of pipes and how many elbows and fittings we've got. So I've got that to help me. We also, from the British Standards 6891 2015, we need a couple of charts. So from this chart here, we can see that how many meters cubed an hour requires how much gas per meter, depending on the size of the gas pipe. But we'll look at that a bit closer. And at the bottom there is also a chart which tells us how many meters we would add on for fittings. Okay, again, we'll look at that in a bit. And finally, we need a sheet like this, which is going to tell us what to do in this situation. Now, when you're designing this pipe layout and your installation, you must take into account the maximum gas flow rate meters cubed an hour going to the appliances. You also should really leave spare capacity on the installation just in case it needs to be changed. So if you wanted to up that boiler to 35, 36 kilowatts, then you should allow spare capacity. But I guess if you did that, you'd never get the job, would you? You also need to make sure we don't have more than a 1 millibar drop between the gas meter and the appliances and their inlet for natural gas. But if it's LPG, it's 2.5 millibar drop. But BS 6891 says it shouldn't exceed 2 millibars on LPG. So these are the considerations you must take into account when you're designing this installation. Now, as usual on Tomcat videos, I've waffled enough. Let's just get on with it now and find out exactly how to pipe size to British Standards 6891 2015. A few things we need to be aware of though before we get cracking and actually do the pipe sizing on here. Now, in the British Standards there are different charts for different pipe material. So whether you're using copper or whether you're using low carbon steel, or whether you're using flexible stainless steel semi-rigid pipe, trap pipe, whether you're using that, then you need to use the manufacturer of the stainless steel flexible semi-rigid pipe. You need to use their manufacturer's instructions to tell you all the details you need, because they don't have elbows, you do the bends. But anyway, so that's another thing you need to be aware of. Now, we are going to be using the meters cubed an hour to find out how we're going to size. So 1 kilowatt requires 0.095 meters cubed of gas, and that's what we're going to be using. There are other scenarios you'll see in other training manuals and other books where they show you how to find that out, but we're going to use the standard of 0.095 for converting our kilowatts net into meters cubed an hour. So I think I've covered everything now, so let's get on with it. Now let's have a look at this drawing more closely. So you can see we've got a G4 gas meter. Our pipe A to B is 4 meters long with an elbow and a T. Our B to C is feeding a 30 kilowatt boiler with 5 elbows. Our B to D is 4 meters long with a T. Our D to E is 2 meters long with 3 elbows. Our D to F has a T. Our F to G is feeding a 6 kilowatt inset live fuel effect fire, 3 meters long with 4 elbows. F to H is feeding a 10 kilowatt DFE with 3 elbows. So that's our drawing. Now all these appliances added together come to 70 kilowatts net. So let's have a look at the next stage then. So the next stage now is to write our kilowatts and then convert it to meters cubed an hour. So if you want to turn kilowatts net into meters cubed an hour, you just times the kilowatts by 0.095. So it's a 30 kilowatt boiler, comes out at 2.85 meters cubed an hour. 24 kilowatt range cooker comes out at 2.28 meters cubed an hour. 6 kilowatt inset live fuel effect fire, 0.57 meters cubed an hour, and a 10 kilowatt DFE is 0.95 meters cubed an hour. So that's the first thing to do, is transfer the kilowatts into meters cubed an hour and fill in this box. Now let's have a look at the paperwork we're going to be filling in as we're going along. We've done step 1. Step 2 we've already done. We've sketched out our drawing. So we've sketched out our drawing, and this is the one we're going to be using. So we've done that. So step 3, it says pipework section, your label. So ours will be A to B, B to C. So if you look at the drawing, ours goes A to B, B to C, B to D, and so on. So that's what we're going to be putting in this section. The next section is our maximum heat inputs in net. So there are net kilowatts and our meters cubed an hour. So we can write those in there. The next one is our estimated pipe size in millimeters. So we're going to guesstimate what we're going to be putting in here. So 15, 22, 28, 35. Our pipe length is taken from the drawing. So you can see here we've got 4 meters, 4 meters, 3 meters, 2 meters, 2 meters, 4 meters. So in our drawing that gives us our pipe length. The next section is for fittings. So what I've taken out of the British standards are these 2 charts. We'll look at this one in a little bit closer, but this one here shows us what allowance per meter we're using for fittings. So whether it's steel or copper pipe, whether we're using bends or we're using 90-degree elbows, and which way flow direction the T is. So whether it's coming into the branch or whether it's exiting the branch, these are the different meters we're going to be adding on for fittings. And this is where we're going to put our equivalent length from the fittings in meters. And this is where we're going to put our total length, where we're going to be adding what we've got there to what we've got there. So what we've got in column 5 to what we've got in column 7 will give us column 8. Then our pressure loss in meters, which we're going to be taking from this table here. So this is our flow rate in meters cubed an hour, or we could use our net kilowatts, but we're going to use our meters cubed an hour. And what we would do is, once we've got our total meters cubed an hour we needed, we look across this line here to the given size of pipe we require. And there is a series of numbers there, which we will then write into this section. And then to get this final figure at the end, whatever we've got in this column, we times it by this column to give us this column. So that's how we're going to be filling that in, and you'll see this as we're going along. So let's take our first section of pipe, which is A to B. And A to B is feeding all the appliances. So we need 70 kilowatts because each appliance added up gives 70 kilowatts. Because from A to B, that pipe has to be able to feed all those appliances. So let's have a look at A to B. So let's start by having a look at A to B. We know A to B is 4 meters long. It's got 1 elbow and a T. So once I've counted this T, I don't need to count it again. And the gas is passing through the branch. So first thing we need to do now is estimate what pipe size we're going to be using. because it has to feed all 70 kilowatts, this first piece of pipe. So it's not going to be fed in 15 or 22 to feed 70 kilowatts. So we'll try 28 mil. So the first thing we need to do is start looking at our sheet. So A to B, we know it's 70 kilowatts because it's feeding all the appliances. And if we look at this here, we need to turn it into meters cubed an hour. So 70 times 0.095, because so 1 kilowatt net requires 0.095 meters cubed of gas. So that's where that comes from. We've guessed at the 28 mil. We know it's 4 meters long from our drawing. So we can see it's 4 meters long. Now we know we've got 1 elbow and 1 T. So we go to the chart here. So for 28 millimeters there, we've got 1 elbow which is 0.8 meters, and we've got a T where it's exiting the branch, so it's 2.3. So if we fill those in, so you can see 0.8 and 2.3. Add those together is 3.1. 3.1 onto the 4 meters gives us 7.1. So we now need to look at our pressure loss from the chart for 6.65 meters cubed an hour. So we get our chart. We now look down here for the closest one to 6.65, which is 6.75. We look across to 28 mil and we can see the figure of 0.0842 here. So let's transfer that over. So you can see we've got the 0.0842. Then what we need to do to find here, we need to do 7.1 times 0.0842 gives us a total pressure loss of 0.59782 millibars. So we've got a half a millibar drop in the first section without even adding an appliance on there. So we look back at the drawing. We can now see we've got a 30 kilowatt boiler, which we need to add on now, and we need to do the same process for the 30 kilowatt boiler. So let's start down here. So let's look at B to C. We know it's got a boiler of 30 kilowatts. 30 times 0.095 is 2.85, because if we look on the drawing again, it's only feeding the boiler, nothing else. We've guessed at 22 mil pipe. So we can see from our drawing, it's 3 meters long and it's got 1, 2, 3, 4, 5 90-degree elbows. So 3 meters, 5 times 0.6, because if we look at our chart here, for 22 millimeter elbows, they're 0.6. We don't need to add the T because we added that last time. So 5 times 0.6 is 3. 3 meters plus 3 meters is 6 meters. Now we need the other chart now. And we go back to this chart because we need to look for 2.85 meters cubed. So we go down here to 2.85, so the nearest one is 3. So we go across here. We guessed at 22 mil pipe, so we need 0.0769. So 0.0769. Now we do 6 times 0.0769 equals 0.4614. Now I ain't no mathematical genius, but to me that's going over a 1 millibar drop. So what we need to do now is, at the top here, we need to go A to B, B to C, because that's feeding the appliance. And you can see we've gone over the 1 millibar drop, so we got 1.05922. So that's a no-no. So what we've got to do now is look back at our drawing and decide what we're going to do. Are we going to increase that size, are we going to increase that size? And the easiest way for us now will to be increase that to 35mm, because it will also help us with the rest of the installation. So we'll leave that at 22 and we're going to up that to 35. Now let's have a look at changing this A to B to the 35, as soon as we've failed with that being 28. So A to B stays the same, 70 kilowatts stays the same, 6.65. We've changed that to 35mm now. We've still got the 4 meters, but our fittings has to change, because if we look at our fittings for 35, a 90-degree elbow is 1 meter, a T where it goes into the branch is 2 meters, and if it goes out of the branch it's 3 meters. So we've got big changes there. So we end up with 1 and 3. So we've got 1 for the 90-degree elbow and 3 for the gas exit in the branch. So that becomes 4. So that now changes to 8. We've still got the same reading here because we're still at 6.65. But then this has to change because we're timesing it by 8 now. So 8 times 0.0263 is 0.2104. So if we look at the top, A to B, B to C to feed this boiler, we've now got a pressure drop of 0.6718. So we're now happy with that, and we can continue now with the next one. Now let's look at B to D. So pretty much straight piece of pipe with 1 T. That's all the fitting. So 4 meters with 1 T. But it is feeding 24 kilowatt range cooker, a 6 kilowatt inset live fuel effect fire, and a DFE. So what size pipe are we going to be choosing there? I reckon we go with 28 and see what that comes out with. So again, B to D, it's 40 kilowatts because it's feeding the 24 kilowatt range cooker, 6 kilowatt inset live fuel effect fire, and the 10 kilowatt DFE. So 40 times 0.095 is 3.8. So we guessed at 28mm. We know it's 4 meters. When we look at our fittings, 28mm, and we've just got 1 T, and it's coming down the branch, so it's 1.5 meters. So we've got 1.5 meters there, 1.5 meters because that's all it is. There's no other fittings. 4 plus 1.5 is 5.5. Now we need to look on the chart again for 3.8. So we look down here, nearest we're going to get is 4. Look across here to 28, so we should have 0.0345. So you've got 0.0345, 5.5 times 0.0345 is 0.18975. So that's our B to D. Next one we need to look at is D to E. Now we've just seen from the drawing we're doing D to E, which was a 24 kilowatt range cooker. 24 times 0.095 gives us 2.28. We're guessing at 22mm pipe. We know from the drawing it was 2 meters, and we also know that if we have a look at the drawing, 1, 2, 3 elbows. So if we look on the chart for 22mm elbows, we can see 22mm elbows, 90-degree elbows is 0.6. So 3 times 0.6 is 1.8. So 1.8 plus 2 is 3.8. So now we need to look down the chart at 2.28 meters cubed. So we look down here, 2.28, nearest one is 2.5. So we go across there to 22mm. which is 0.0565. So 0.0565. Then we do 3.8 times 0.065 equals 0.2147. Now, what we have to do at the top now is, because of the way the gas is going, so the gas to get down to here needs to go to A to B, B to D, and D to E. So you can see here A to B, B to D, D to E, and if we add those up, it comes to 0.61485, so that's less than a 1 millibar drop, so we can say yes. Now let's have a look at D to F. So we can see D to F is feeding our 6 kilowatt inset live fuel effect fire and our 10 kilowatt DFE. So 16 kilowatts it's feeding. So we've got D to F, 16 kilowatts. 16 times 0.095 is 1.52 meters cubed an hour. We're going to guess at 22 mil pipe. We know it's 2 meters, and we know there's 1 T. So if we look at our chart for the fittings, so we know it's 22. We know the gas is going through the branch. So 22, so it's 1.8 meters. So 1.8, 2 plus 1.8 is 3.8 because there's no other fittings. So then we need to look on the chart now for our 1.52. So we need to look down 1.52, so the nearest one is 1.75. We look across the 22 mil pipe, which is 0.0311. We then look here, 0.0311, and we do 3.8 times 0.0311 is 0.11818 millibar drop. So that is our D to F. Now, our next appliance is F to G, which is the inset live fuel effect fire. So let's have a look at that. So you can see from the drawing, F to G is 3 meters long with 4 elbows. So let's have a look at that. So you can see F to G, it was a 6 kilowatts. 6 times 0.095 is 0.57. We're going to guess at 15 mil. So the pipe is 3 meters long. We need to now look at the chart for the fittings. So we can see 15 mil, 90 degree elbows is 0.4. So we can now do 4 times 0.4 is 1.6. 1.6 plus 3 is 4.6. Then we need to look down the 0.57. So we look down here. So nearest one is 0.75. Look across to the 15 mil, which is 0.0447. So 0.0447. 4.6 times 0.0447 is 0.20562. Now, what we've got to do again is, because it's going from A to B, B to D, D to F, F to G, we're not allowed a 1 millibar drop, more than a 1 millibar drop for that. So if we go back to our chart, you can see we've got A to B, B to D, D to F, F to G, and when we add all those figures up from there, we get 0.72395 millibar drop, which is less than a millibar. So we can deem we've sized it correctly. So the last one we need to look at is F to H, which is just feeding the 10 kilowatt DFE, and there are 3 elbows. We've already counted that T, so we just got 3 elbows. So let's look at the final calculation. Now, here goes with the final one. We know it's F to H. We know it's 10 kilowatts feeding the DFE fire. So 10 times 0.095 is 0.95. We're going to guess with 15mm pipe. We know it's 4 meters long. We know we've got 3 elbows. So on the chart, 15mm 90-degree elbows is 0.4. 3 times 0.4 is 1.2. 4 plus 1.2 is 5.2. Then we need to find 0.95 on our chart. So we'll look down here. So the nearest one is 1. So if we go across to there, to 15mm, so it comes out 0.0719. So 0.0719. So we do 5.2 times 0.0719 is 0.37388 millibar drop. Now, because this is feeding an appliance, we can see from our drawing we need to go A to B, B to D, D to F, F to H. So we go up to the top, A to B, B to D, D to F, F to H, and if we add those figures up, we come to 0.89221 millibar drop. So that's another yes. So that's how you fill in the sheet. And again, guys, if I've made any mistakes on the maths, don't kill me, because it is a pain doing all this. So this isn't how to do the maths, this is how to do it, how to work it out. So if I've made a mistake on any of the figures and you find them, don't put any comments down at the bottom telling me, because I probably already know. But anyway, that's how you complete the sheet. So let's sum up then. And that's the long-winded way of pipe sizing. Now there's going to be guys out there going, well, I'm not doing that, it takes too long, I'll use an app. Well, apps are good for telling you, going to a job and seeing if the guy who fitted it before you had installed the right size pipe, but they're not very good for actually doing this, because they only do one section at a time, so they are a bit of a pain using an app that way, and I can't ever get an app to work correctly. But anyway, that might just be me because I'm an old fossil, but there you go. So that's how you pipe size correctly to the British standards, and you will also have to do that in your ACS exams, whether it's initial or resit. It's not as complicated as that, so don't start panicking. It's nowhere near as complicated. But if you want to size a gas pipe correctly and accurately, this is the system and the way you need to do it. So if you've liked this video, why don't you give me the thumbs up, or leave a constructive comment below. If you think apps are better, then put it down below. If you're not subscribed to our channel, then please subscribe, because it helps. And again, I'm over 5,000 subscribers, so thanks very much for everybody who subscribed. But don't forget to hit that notification bell, because we release videos mainly on Mondays and Wednesdays. All I've got left to say as usual, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers.